Yeah, what we're doing now is basically building the final features of the protocol that we want to release for Mainnet. We've put in stuff like hash time lock contracts for atomic cross-chain transactions. What else?
For example, we also removed finally the nonces from the transactions, so that we can also prune the accounts tree, and if a balance goes back to 0, we can remove the account from the list of accounts again.
We've started like writing up a real documentation of the protocol, which will also be useful for the bug bounty program, which is in preparation and will hopefully start within the next couple of weeks. Internally, we always compute in the smallest unit of Nimiq, right? So like moving the comma around is basically just what you call a nim, right? And we can, if we decide later on that we'd like, you know, have even less digits after the comma, that we have just only 2 digits after the comma, so that 100 satoshis will be one nim. That will just be something that we kind of sort of need to agree on, but which doesn't have any like technical implications apart from the fact that the user interfaces would basically, you know, wherever you see MBTC right now, you would see BTC instead.
New member to the Nimiq dev team here.
We'll show your face. I was mostly working on different components that the apps are made of. So we are working currently on a growing library of components that are reusable between our apps and projects. And I'm just working on a couple of new components. We changed the dependency management of those components. So an app is built of a couple of components, and before we had to handle all those dependencies by hand. So for every new app that you build, you have to list all the dependencies, and now the dependencies are listed for every component. And if you want to create a new app, you just have to specify like the root element, and then it collects all the dependencies automatically.
I'm mostly working on the documentation, because as we approach Mainnet, that's a really important part, both for our developer users, as for having the specification in case, you know, somebody else wants to create a node, or for bug bounty programs, for example. That's really important, so that people who are going to try to find vulnerabilities can actually know if something is a vulnerability or something that was intended by us.
We just finished the hash time lock contract, which is used for atomic swaps, which allow to do transactions that are basically doing a transaction on the Ethereum blockchain and the Nimiq blockchain at the same time, which will allow basically to use your Nimiq funds to do transactions on other blockchains if they support it, like Ethereum. And yes, that's the last thing we merged. And I'm also currently working on a JSON RPC API, which is like an API used by, for example, exchanges or other developers to easily integrate cryptocurrency. And then we try to design our API similar to the Ethereum and Bitcoin API, so it's easy for existing tools to move over to Nimiq.
I've been working on the front ends, and the idea is to develop lots of elements, which then the apps are composed of. And yeah, we have already a couple dozen elements built. And see here, for example, this is the view to back up your recovery file. You need to enter a password and press next. We've built dozens of such little components. This is like the counterpart. This is import the backup file. Where do we have it? So when you have written down your phrase, with this one you can check if your backup is correct. It asks you to select the 5th word that you wrote down. Yeah, well, it's a bit to like force the user to actually write down the phrase. This is a very important step, since we don't back up your key in any way. and if you lose your key, your funds are lost. And to prevent that, we want to like annoy you a bit to actually back up your phrase and make sure you have backed it up correctly. For the backup files, we're using images with embedded QR codes, because images are easier to handle than like a JSON file or something. Especially on mobile, you can use the gallery to see the images and stuff like that. And images are just like, because you have a preview and stuff like that, they're easier to handle than usual backup files. And we needed to test it off our backup files if they actually work, and therefore Daniel wrote a fuzzer, and I want to show it to you because it looks quite cool. And what it does, it creates 10,000 random backup files, and it looks if it can actually read them afterwards. Because it would be very horrible if you create a backup file that is not readable anymore. And this attempt worked quite well so far. We've done like 1,000 iterations and no failed sample. But if you do about 10,000 iterations, 6 on average will fail. And therefore we need to build another mechanism that ensures that every backup is readable. Potatoes, French fries.